everyone to our lesson today on rational exponents and radicals. This lesson is going to be brand new to you. It's going to be something that you have probably never seen before. So for those of you at home, feel free to send any questions my way because it is a little bit tougher in the fact that it's just new material. So again, don't hesitate to reach out. Okay, so our goal today is to rewrite expressions involving radicals and rational exponents. Okay, so rational just means it could be a whole number, it could be negatives, it could be positives, it could be decimals, but in this case today we are dealing with fraction exponents. So we're kind of going to discover what does fraction exponents means. So like if I have 4 and I'm raising it to the 1/2 power, what does that really mean? So we're going to kind of discover that today. And it's going to relate to radicals, which we're going to talk about radicals on the very next page. Okay, so a radical expression. So a radical expression means that there is some kind of root. You guys are used to seeing square roots, but square root is not the only kind of root. We also have a cube root and a fourth root, and it could keep up going on forever. So the number under the radical sign, so the number under the root, is called the radicand. So you can see it in the picture right here. That A is the radicand. The number n in the crook of the radical sign is the index. So again, you can kind of see that on our thing right here, the index. The index gives the degree of the root. For a cube root, the degree is 3. If there is no index, the degree is 2, which means square root. So again, you guys are used to seeing the square root of 9. So there is technically an imaginary 2 there, square root. But we don't write 2. And you guys all know that the square root of 9 is 3. And if you think about the reasoning of why, it's because you're thinking, what number, if I square it, would give me 9? So keep that in mind, because I'm not going to be doing squared. This is going to be changing today. Okay, so for example, we are going to find the cube root of 125. Now there is a way to type this in on your calculator, but there's also a way to do it without a calculator. Okay, so I'm trying to figure out what number to the 3rd power is going to give me 125. So if you're finding the root of something, it should be getting smaller. Okay, so what number to the 3rd power would give me 125? And our answer here would be 5. You might have to guess and check, or some of you might be able to figure that one out, kind of by logical reasoning and the fact that it ends in a 5. Okay, so the next one, you would think, what number to the 4th power would give us 16? And that answer would be 2. 2 to the 4th power would give us 16. So we're kind of going backwards from what you're used to. You're used to raising something to a power and telling me the answer. Well, I'm giving you the answer and I'm asking you what number is raised to that power. All right, so the next one, what number to the 3rd power is going to give me 216? Now this is a tougher one. Some of you guys might be able to figure that out though. It's the number 6. Because 6 times 6 times 6 would give us 216. All right, the last one's the toughest one of all. What number to the 5th power would give us 1024? Because 1024 is fairly large, you would think it's a pretty big number, but this answer is actually 4. 4 times itself 5 times would give you 1024. All right, go ahead and pause the screen here and see if you can answer these 4 questions. All right, here's the answers that you should have gotten. So what number to the 3rd power gives us 27? Well, that answer would be 3. What number to the 5th power would give us 32? That is the answer of 2. What number to the 3rd power gives us 64? That answer is 4. And last, you guys are used to the square root. So what number to the 2nd power gives us 36? That answer is 6. Okay, so now that we understand roots a little bit better, the different kinds of roots, we are going to get into rational exponents, which are going to be connected to our roots. Okay, so I'm going to show you the answers to these 3 questions. I want you to pause and see if you can figure out what the rule is, and then we'll go over the rule and I'll have you try 2 more on your own. Okay, so 49 to the 1/2 power, that answer is 7. 64 to the 1/3 power, that answer is 4. And 16 to the 1/4 power, that answer is 2. See if you can pause here and see if you can discover the rule on your own. All right, here is the rule. The rule is that the denominator, our bottom number, becomes the index of the radical. I tried to use vocabulary there. All right, so in this case, we would take 49, we put the radical around it, and the denominator becomes the index. So in this case, that'd be the square root, which I don't actually have to write the 2 out front. It's implied. So the square root of 49 is 7. Okay, I would take 64, put it under a radical. The denominator goes outside. So this would be what number to the 3rd power gives us 64? And that answer was 4. All right, if I took 16, put the radical and to the 4th root, so what number to the 4th power would give us 16? And that answer would be 2. All right, see if you can try these next ones on your own, these last 2. Go ahead and pause here. All right, here's what you should have gotten. So you take the number, or the base, we put it under the radical. Our denominator is the index. So we have the square root. Again, you don't really need to write the 2 there. Of 81 is 9. So our answer here was 9. Again, 81 is our base. So it's going to go underneath the radical, and it's going to be to the 4th. The index is going to be 4. So the 4th root. All right, so what number to the 4th power is going to give me 81? That answer would be 3. 3 to the 4th would give me 81. Okay, so let's try another one. So we have now done rational exponents, where 1 is the numerator, and then we have a different denominator. So on this next slide, I'm going to add in another numerator instead of 1. Okay, so let's see how that changes it. Again, we're going to see if you can discover the rule. All right, 8 to the 2/3 power is 4. 9 to the 3/2 power is 27. And 32 to the 4/5 power is 16. See if you can pause here and discover the rule on your own, and then we'll go through it together. All right, so we're just going to add to the rule that we had last time. So the denominator still becomes the index of the radical. So I'm going to keep that. So the denominator becomes the index of the radical. So that did not change. The numerator stays as an exponent. All right, so let's look at the two examples again. So keep your 8. We are going to put it under a radical. I'm going to take the denominator and put it as the index. I haven't done anything with the 2 yet. So I'm going to figure out what is the cube root of 8. So what number cubed will give us 8? That would be the number 2. Then I take the exponent and the numerator, and I keep it as the exponent. So 2 to the second power is 4. Now, I'm not going to lie, guys, this lesson is a little bit tougher. It gets into algebra 2 some, so this is kind of an introduction, and you'll use it again in the future. But you guys can handle it. All right, so let's look at the second one. Okay, we're going to take 9. We're going to take the denominator. That becomes the index. So we have the square root of 9, which we know is 3. Then we take the numerator and raise it to that power. So 3 to the third is 27. All right, last one here. 32. Going to put it under the radical. We have 5 out front. Okay, so what number to the 5th power gives us 32? That answer would be 2. Then take your numerator and we're going to raise it to that power. So 2 to the 4th power would be 16. All right, go ahead and pause here and see if you can do these last two on your own. Okay, let's see how you did. So we take 27, we put it under the radical, and the index is 3, the denominator. So what number to the 3rd power gives us 27? And that would be 3. Then we take our numerator and we raise it to that power. Our answer to this one should be 9. Okay, last one like this. We take 4, we put it under the radical. 2 is the denominator, so what's the square root of 4? Well, that is 2. Now we come back to our numerator, so 2 to the 5th power. That would be 2 times 2, 5 times. And sometimes I will do it without a calculator. I will kind of put them in pairs. So 2 times 2 is 4. 4 times 4 here times 2. And you can do it again out of order, doesn't matter. 4 times 2 is 8. And 8 times 4, this answer should be 32. Again, you can use a calculator or you can do it by hand, or some of you just might have that one memorized. Okay, so let's get one step different. I'm not going to say tougher. In my opinion, it's actually a little bit easier, but it's something you're not used to. So on these, we started with a number base. The next slide, we're going to have variable bases. Okay, so I'm not going to be able to simplify these. I'm just going to rewrite them. Okay, so notice in the directions, it says convert. Convert just means to change. So I'm not simplifying this whatsoever. I'm just changing the way it's written. I don't want it to be written with a fraction exponent. I want it to be in radical form. Radical means we want there to be some kind of root. Okay, so I'm going to take my base, which is a. I'm going to put it under the radical. Remember, the bottom number 3 is the index, and the top number is the exponent. And so you can put that exponent outside, or you can take that exponent and put it inside as well. Both would work. All right, we're going to do the same thing for b. We take our base, we put it underneath a radical. Now, our bottom number, our denominator, is a 2, so it's implied. We don't actually write a 2. You guys have never seen a square root with a 2 there, so I'm not actually going to write that one. But I am going to write the 3 as our exponent, the numerator. Let's see if that was exactly what they had. Yep. All right, this last one's a little bit tougher because if you remember, 5's exponent is that ninja 1. So the 5 is not the problem. The 5 is going to stay where it's at. But the d is the one that has the fraction exponent. So we're going to put d underneath the radical. We have our denominator of 4, so it's going to be the 4th root. And then we have our numerator as 3, so that's going to be your exponent. And that's what is there. All right, go ahead and pause the screen here and see if you can do these last two on your own. All right, let's see how you did. So e, your base, goes underneath the radical. Our denominator is the index, so it's the cube root. Our numerator is the exponent. This should have been your answer for the first one. All right, the second one, f, should be underneath the radical. Now it's squared, so I'm not actually going to write it. But I am going to write to the 5th power, and that would be your answer for that last one. All right, we're going to do 2 more slides here. All right, notice it says converting again. So converting, remember, means to change. Doesn't mean to make it easier. We're just going to change the form that it's written. This time we want exponential form. We want it to have an exponent. Okay, so we're going the opposite direction of what we just did. Okay, so first off, we have to identify what the base is. So on this first one, our base is g. And if you remember, the denominator was the same as our index. So our denominator is 4. And our numerator was the same as the exponent. So this would be g to the 3/4 power. Okay, let's try another one. H was our base. Our index, our denominator, was 3. And then our exponent stays in the numerator. So h to the 2/3 power. Now, 8 has nothing to do with the radical, so keep 8 out front. Our base is I. Okay, so now we have the denominator, and here's the hard part, because there was nothing written there, which that means square root. So our denominator is 2, and our numerator is the exponent, so 4. And then even though this looks crazy, that's still a fraction, and you don't disregard everything you know about fractions. Anytime we see fractions, we always simplify. All right, so we are going to simplify that to 8i to the 2nd power. That is the better way of writing it. All right, so last one here is j. We have our base is j. I have a root with no index, so that means it's a 2. We don't write it when it's a square root. And our numerator is also 2. Again, what we know about fractions, we don't keep it as 2/2. This is the same thing as just j to the 1st power, or better written as j. Okay, so now that we kind of understand what a fraction exponent means, our main goal is to be able to do operations with our fractions. Okay, so we're going to simplify these using what we have already learned, which was our MA problems, DS problems, and PM problems. Remember, MA problems were for multiplication problems. DS was for division problems. And PM was raising something to a power, so power problems. Again, first letter tells us what to do with the coefficient. Second letter tells us what to do with the exponents. Again, coefficient, exponents. And last, coefficient and exponents. Okay, so that's what that acronym is, kind of a shortcut to remember everything. All right, here, the operation going on between those two is multiplication. So we are following the MA rules, where we multiply coefficients and we add exponents. Well, we don't have any coefficients. We do have 2 bases. We always keep our bases the same. and we are going to be adding our exponents. So I have to do 3/4 plus 1/2. And here's where fractions come back into play. If I'm adding, I need common denominators. So I have 3/4 plus 2/4, and that would give us 5/4. Okay. Now it said to simplify, which we did. Now it says to write in radical form. Okay, so let's take this a little bit further. Radical again means I need that radical symbol or that root symbol. So I have k as my base, and I have my denominator is my root, or my index of my root, and my numerator is my exponent. Okay, so we actually have two answers here. We have k to the 5/4 power, and that is also the same as the 4th root of k to the 5th power. So this is exponential form, and this is radical form. They are both the exact same answer, just in different forms. So it kind of depends if on a test, which form it was asking for, which way you would answer this. Okay, so we're just gonna do both for right now. All right, problem 2 here. We have one monomial raised to a power. So this would be a PM problem. So I would power up the coefficient, but I don't have any coefficients, so I don't have to worry about that. I do have a base, so I'm gonna keep my base, and I need to multiply my exponents. So out to the side here, I have 5/2 times 4/5. And if I have a 5 on top and bottom, I can cancel those out and make them 1s. I can cancel out the 2 and the 4, make it a 1 and a 2. So this ends up being 2/1, or 2. So m to the 2nd power. And if I have to write that in radical form, I really can't, because I don't have a fraction exponent. So my answer would just be m to the 2nd power. All right, now this last one, your test does not get this difficult, but I threw in this one just as a challenge. We have two types of problems, okay? We see multiplication here, but we also see a power problem there. So if I'm thinking about PEMDAS, what comes first, multiplication or exponents? Exponents comes first. So I'm going to do my power problem first. So I'm going to pull out this part of the problem. So I'm going to keep n to the 2/3 down here, but I'm going to answer this part of the problem first. Okay, now I have to distribute that 1/3 to each of these. So I have 8 to the 1/3 power, and I also have n to the 1/3 power. Okay, so I want to clean that up a little bit. I want to clean up my coefficient. So 8 to the 1/3 power means I have 8, and I have it under a radical, and I am finding the cube root of 8. So what number to the 3rd power gives me 8? And that would be 2. 2 times 2 times 2 would give me 8. And I'm going to keep my n to the 1/3 power. Okay, so I did a PM problem up there. Now I have a multiplication problem here. So I'm doing MA. I multiply coefficients. Well, the only coefficient is 2, so I'm going to keep the 2. I keep my bases, and I'm going to have to add my exponents. So 2/3 plus 1/3 gives me 3/3, which is equal to 1. So this would be n to the 1st power, but I'm not going to write that because we don't need to write the exponent of 1. And that would be my answer on that last one. All right, again, if you have any questions when you're working on tonight's homework, first check the answer key so you can see my work, and then also don't hesitate to reach out. Hope to see you guys soon. Bye.